Welcome back, guys, to Mr. Morrow's Algebra 1 and 2 class. Today we're going to be talking about relations and functions. I know that I say this often, but I mean it. This is really important as well. Relations and functions are something that you've been working with for a long, long time. The problem is that a lot of teachers don't take the time to really show what it is. So I'm going to start from the beginning, and hopefully we'll finish this up the right way. Before I can really talk to you about relations and functions which deal with ordered pairs, I want to tell you what these ordered pairs are and, a little bit of a reminder of the coordinate axis plane. Now, you see this coordinate axis plane. The y-axis refers to this vertical up and down line. Okay? That is the y-axis. Now, this horizontal line is the x-axis. Okay? Most of you guys know that. It's horizontal, kind of like the horizon when you look at the beach. When you're at the shore and you look out into the ocean, it's just across. It's horizontal, horizon. All right? So that's the x-axis. Now, the x-axis is known as the input, because when you're plugging something into an equation, that's the input. For example, let's say you're going to go on a date with your girlfriend and you go to the movies. It's $10 a movie, right? Think about this. Doesn't your cost equal $10 times every ticket? Guys? Yeah, right? So if it's two of you, how much are you going to pay? Okay, and how would you figure that out? Because you go 2 times 2. Tickets is 2, right? That's what the input is. Didn't I input this 2 into the equation? Okay, so that's input. Now, the x-axis is or the x values are known as the independent variable. It's independent because can I go to the movie theater and choose to buy 0 tickets? No, you're not allowed to not buy tickets. Think about that question, guys. You go to the movie theater. Oh, I don't want to watch this movie. Do you have to buy a ticket or do you have a choice? So can you buy 0 tickets? Yes, you just don't buy anything. You go somewhere else. So can you buy 10 tickets if you wanted to? If you wanted to and you had the money, could you buy the ticket for every single person standing in line? That's what's meant by independent variable. Independent means it can just be anything it wants. The x values are also known as the domain. The domain is all of the possible x values in a function. We'll get into what a function is in a second. The y-axis. Excuse me. The y-axis is known as the output. On that example that we had, where we want to know the cost of movies, and it's $10 for every T ticket, okay? Let's say I want to take my family, so I buy 5 tickets. My cost is $50, right? That's the y value. That's the y. That's the output. That is the output that depended on the input. Doesn't the cost of the movies increase the more tickets you buy? So the cost is dependent on the number of tickets, correct? So that's why it's called the output and also the dependent variable. The y value, the dependent value, depends on the x value. The dependent value depends on the x. And then all the possible set of y values is called the range. Now, this little red dot here in the center, that bad boy is the origin. I don't know if you remember that. The origin has the ordered pair 0, 0. Now, some of you may say, whoa, you said ordered what? Ordered pair. An ordered pair, I know you know it, guys. It's a point. An ordered pair is a point on an XY coordinate graph. It's called an ordered pair because it's in alphabetical order. The X goes first, then the Y. For this particular example, gentlemen, I went 1, 2, 3, 4 on the x-axis, 1, 2, 3 on the y-axis. So my ordered pair is 4, comma 3. The 4 represents the location on the x-axis. The 3 represents the location from the y. Does that make sense, gentlemen? None of this is in the book. I'm letting you know this so that now we can really have a good session. Does that make sense, brothers? Okay. Now, a relation. A relation, guys, is just any set of ordered pairs. Remember, we just talked about that. An ordered pair is an input or x, comma, output or y. Right? That's the xy point. It's a point on the x and y axis graph. Any set of ordered pairs is a relation. There are 4 ways that you can write a relation. First of all, you can just list all of the ordered pairs. For this particular relation, you have the ordered pairs 1, 8, 1, 4, 2, 9, 3, 2. So you could just list the ordered pairs and you're golden. You're good. No worries. List them. Number, I don't know why I said number 3. It should be number 2. I apologize about that. Let me fix that. Sorry. Number 2, my bad. It's a mapping diagram. Now, check out this mapping diagram. In the mapping diagram, you have 2 columns. You create an input column. The input, of course, is all the x values or the domain. And then you create an output column. Those are all of the y values or range. You don't have to put them in any particular order. The domain, okay, according to this right here, the domain, you have a x as a 1, another 1, a 2, and a 3. I don't need to repeat domains. So my inputs here, my domains are 1, 2, and 3. My output are all the possible y values. In this particular example, gentlemen, I've got 2, 9, 4, and 8 as possible y values. So therefore, my output table, I put 2, 8, 9, and 4. And now, what are these arrows? Well, when I have the input value of 1 for x, don't I get an output of both 8 and 4? According to this. When I have an input value of 2, isn't my output 9? And when I have an input of 3, isn't my output 2? Does that make sense, gentlemen? You promise? Yeah? Okay. So far, so good? I can scroll up, but since it's a video, I'm not going to. Thank you, though. All right. Now, number 3. Table of values. You can create an input-output table. Similar to the ordered pairs, except it's actually in a table now. And you make a little table. You make a 2-column table. You label one of them X. Okay. You label the other Y. And you plug in all the X values, which I'm using the same number so you can see how it corresponds. 1, 2, 3, and 1. 1 corresponded to 8 according to our original ordered pairs. 2 corresponded to 9. 3 corresponded to 2. 1 corresponded to 4. So that's the third way to describe or represent a relation. And the last way, guys, you can graph it. You can graph these points that we have right here. The 1, 8, the 2, 9, the 3, 2, and the 1, 4. And you can graph that just as shown right there. This is 1, 4, 1, 8, 2, 9, 3, 2. Does that make sense, my brothers? Sir. Okay, thank you for asking. The question was not related to this, but it is kind of. He asked for what are the quadrants of the coordinate axis plane. Okay, quadrants go from right to left counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 4. Thank you, son. Does that make sense, boys? Okay, awesome. Let's continue. All right, now, what are the domain and the range? We already talked about this, so you guys tell me. What's the domain for this relation? Anybody? Go ahead, -3. So make a little brace, -3, 0, 2, 9, 23. What's the range for this relation? 14, 7, 0, -18, -99. Perfect, son. Make sense? Everybody sees that, right? Yes, sir. Okay, the question was, when we're writing it out, do we have to put it in order from least to greatest? Not necessarily, son. No. I mean, it helps the reader, and it's going to help you if you put it in order. But, you know, if you're in a rush or you're in a test or something, you know, it doesn't really matter, sir. Thank you. Sir. Yeah, in this particular example I happen to put the domain in order, but not the range. Thank you, brother. Does that make sense, boys? Okay, now, functions. This is where it all comes together. Please pay attention to this, okay? Don't even write this down, guys, for right now. I really want you to focus. Remember, you have this on video. I really need you to listen. A function is any relation. So a function is a relation. Any relation where each element of the domain corresponds with exactly one element of the range. So let's do it in English. In other words, a relation is So in other words, a function, Okay, it's a function where there can only be one y value for any given x value. Okay? And actually, no, I was right. In other words, it's a relation where, see, I don't know why I second guessed myself. Sorry. Yeah, in other words, a function is a relation, because it's any relation, where there can only be one y value for any given x value. Let me explain this by example. Okay. I have 1, 8, 2, 9, 3, 2, 1, 4. Do you see how I have two different y values for the same x value, gentlemen? That is not a function. You cannot have different y values for the same x value. You cannot have different y values for the same x value. How about here? I got 1, 8, 2, 8, 3, 8, 1, 8. Is that a function or a relation? It's a function. Now, let me explain to you. You guys say, wait, hold on, Moro. The y's are constant, the x's are changing. You can have that. You can have that. What can you not have? You cannot have this one. 1, 8, 1, 9, 1, 2, 1, 4. You cannot have different y's for the same x. But you can have the same y for different x's. Does that make sense? You cannot have different y's for the same x. You cannot have different y's for the same x, but you can have different x's for the same y. How about here? 1, 3, 2, 5, 3, 7, 4, 9. Yes. How about here? 1, 5, 1, 9, 3, 2, 4, 8. No. You cannot have two different y's for the same x. Does that make sense, boys? Yes, sir. What do you mean? I don't understand. Okay, 1, 8, 1, 8. What was the y value when x was 1? What was the y value when x was 1? That's a function. You cannot have different y values. You cannot have 1, 8 and then 1, 7. That's not a function. Sir? If it's not a function, it is straight up a relation. Yes, sir. Thank you. Good questions. Okay. Yes or no to a function? 4, negative 1, 8, 6, 1, negative 1, 6, 6, 4, 1. Okay, some are saying yes, some are saying no. Yes, it is, guys. Oh, no. No, it's not. No, it's not. Psych, I was just testing you. No, why? 4, negative 1, 4, 1. You cannot have different y's for the same x. How about this guy? Nah, that works, that works. Yes, good job. What? Opposite sixes, that can work. That works. So, you can have the same y for different x's, but you cannot have different y's for the same x. Okay? So this is a yes. That one's no, but that one's yes. Does that make sense? Now, last part. Oh, no, almost. Vertical line test. Sometimes they'll give you a graph, and they'll say, is this a function? Well, we know that if you have an x value, and it corresponds to two different y values, it's not a function, right? Well, let's think about this for a second, my brothers, because you're going to love this. There's a value here. Let's just say that the x value there was 2. You with me? If I create a vertical line through this 2, isn't this going to be 2 and a y here? So that will be 2 comma y1, whatever the value is, right? But am I not hitting a second y value here? 2 comma y2? Can I have two different y's for the same x? So that is not a function. You can use what's called the vertical line test. The vertical line test, again, helps determine whether a relation is a function. The vertical line test states that if a vertical line passes through more than one point on the graph of the relation, then the relation is not a function. Again, why? Because at this particular x value, okay, let's say that this was 3 and this is negative 3. For these 2 points, you got 2, 3 and 2, negative 3. Is that a function? No. So that's a big fat no. Here, when I do a vertical line test, how many places does it hit? Yes. Every x only hit one particular y value. You feel me? How many did it hit? So for this particular x value, I have two different y's, right? So is that a function? How many does that hit? So for that particular x, I have two different y's, right? So is that a function? Does that make sense? Okay, now the easy part. I promise. Function rule. Okay, guys. It's easy, but this will be with you guys for the rest of your mathematical careers. And I know that you guys all saw this last year. Function rule is an equation that represents an output value y in terms of an input value x. You can write a function rule in function notation. Shown below are examples of function rules. Basically, guys, a function rule is an equation that stays the same forever. For example, when you guys go to McDonald's or Burger King, they have a function rule. A Big Mac costs $3.98, right? That's their function rule. And they'll write it like this. F of x equals, whatever, 298 x. X equals the number of Big Macs you buy. This is in the computer. This is programmed. That's a function. And I'll be right back. All right. Okay, sorry about that, guys. Now, let me give you examples of what's going on with the function, okay? When they give you a function in this format, y equals 3x plus 2, this is a function. Y is the output, and x is the input. Done. Input, that's where you plug in values, and then you get an output, which is the answer. Now, you can also go f of x. F of x is a fancy way of writing y, I swear to God. This is read as f of x, but what does that really mean? What it really means, guys, is they're telling you, hey, dude, this is function f with independent variable x. That's all they're saying. Hey, dude, this is function f with independent variable x. If I gave you g of t equals 2t minus 7, they're telling you, hey, dude, this is function named g with independent variable t. Does that make sense, guys? Hello? Okay, kind of. Why kind of? Thank you. Why kind of? No, this is, well, I can give you g of t, f of y, j of k. They're all individual functions. That's why I said this is function g with independent variable t. This is function f with independent variable x. But f of x is the same thing as saying y. They're both outputs. Yes, sir.
So when you get what x is, will that become f?
Hold on. Don't run before you walk. Hold on. Give me 1 second. Are you on with me so far with the first two that I did? Hello? Yes, no, maybe, kind of, sort of? Okay. Now, over here, you got f of 1 equals 3 times 1 plus 2. The function was function f with independent variable x. Sometimes they're going to ask you for the following. Find the value of the function when x is 1. So aren't you replacing x with 1 here? So the function f when x equals 1 is 3 times 1 plus 2. So function f when x equals 1 equals 5. You do not solve for this f. That is not a variable. That is just a fancy way of saying y. F of x is the same thing as saying y. Yes, sir. We're going to have a lot of different numbers. Sometimes they'll say x is 1. Sometimes they'll say x is 9. Sometimes I'll give you 7 values of x. Yes, sir. No, you cannot isolate the f because the f is not a variable. If I want to find this function value when x equals 2, okay, f of 2 would equal 3 times 2 plus 2. What is this f of 2 telling you? It's saying, hey, reader, this function f when x, the independent variable, equals 2. F of 2 is the y, it's the answer. So f of 2 will equal 8. The value of function f when x is 2 equals 8. Does that make sense, son? Okay, now, last thing, guys. Example, actually, no, I think we have a little bit more. Example 3. For f of x equals negative 2x plus 5, what is the output and for the inputs? Negative 3, 0, and 1/4. Okay? You do one of two things here, guys. Hold on. I'm sorry, just bear with me. One of two things. You can make a table. When x is negative 3, 0, and 1/4. And then plug it in. Negative 3 times negative 2 is 6. 6 plus 5 is 11. Negative 0 times negative 2 is 0 plus 5 is 5. Negative 2 times 1/4 is negative 1/2. Negative 1/2 plus 5 is 4.5. Or you could go f of negative 3 equals negative 2 times negative 3 plus 5, which equals 11. F of 0 equals negative 2 times 0 plus 5, which equals 0. Or f of 1/4 equals negative 2 times 1/4 plus 5, which is going to equal 4.5. So when they're telling you to plug in and find output values, remember, the output is the f of. The output f of negative 3 equals 11. The output of f of 0 equals 5, not 0. The output of when x is 1/4 equals 4.5. Okay? I know you guys want to go, so I'm going to skip number 4. But please do them. Do them for yourselves because it's easy. And last thing I promise. Let's put it all together to write a function. Okay? Tickets to a concert are available online for $35 each plus the shipping plus a handling fee of $250. The total cost of the function is the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. You could do this one of 2 ways. Y, which is the total cost, equals $35 for every X ticket plus $250. Or, what's another way to write Y? F of X equals 35X plus 250. One thing you got to do here, though, tell me what X is. X is number of tickets, right? Does that make sense? I'm not going to solve these. I know you guys want to get out of here. You're buying bottles of sports drink for a softball team. Each bottle costs $1.19. What is the function rule that models the total cost of the purchase? F of X equals 119 for X, where X is the number of bottles. Evaluate the function for 15 bottles. F of 15. What is the value of function f when x is 15? 1.19 times 15. I won't bore you with the math. Thank you for your patience. God bless you all. Have a great day. Hasta la vista. Homework is valid.